So hello everyone, myself Vinay Kumar. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous video, I had actually explained about the midpoint theorem and the converse of midpoint theorem, that is theorem 8.8 and theorem 8.9. That was 8th chapter in 9th standard mathematics, which is on quadrilaterals. Now we will move into the next and the last exercise in this particular chapter, that is exercise 8.2. So in this particular exercise 8.2, we will look into the first question. So we will look into the first question. Here in the first question, we have a quadrilateral like this, A, B, C, D. So here the midpoint of AD and the midpoint of DC are connected with each other like this. So here S and R are the midpoints of AD and DC. And we have midpoint on AB, that is P, and we have midpoint on BC, that is Q. So here SP is also connected and PQ is also connected, and this particular RQ is also connected. So based on this, and we have one diagonal AC. So and we have one diagonal AC like this. So based on this particular data, we need to prove that three questions in this particular first question. So first we look into the first question inside first question, that is we need to prove SR is parallel to AC and SR is equal to half AC. So now here consider triangle. So here consider triangle ADC. So that is, we'll consider this above triangle ADC. So in which S and R are midpoints of DA and DC. So here S and R are midpoints. S and R are midpoints of DA and DC. So therefore SR is parallel to AC and SR is equal to half times AC. This is according to midpoint theorem. So this is according to midpoint theorem or theorem 8.8. So now we have proved SR is parallel to AC and SR is equal to half times AC. So now we look into the second question. Here you need to prove PQ is equal to SR. So here you need to prove PQ is equal to SR. That is, this particular line PQ is equal to SR. So in order to prove that, we'll consider the below triangle ABC. So consider triangle ABC. So consider triangle ABC. Here in this particular triangle ABC, P and Q. So P and Q are midpoints. So P and Q are midpoints of AB and BC. Therefore here PQ is parallel to AC, PQ is parallel to AC, and PQ is equal to half AC. This is also according to midpoint theorem. This is also according to midpoint theorem. PQ is parallel to AC and PQ is equal to half AC. So this you consider as equation 1 and this you consider as equation 2. So therefore from equation 1 and equation 2, what we have in equation 1? Equation 1 we have SR is equal to half AC, and in equation 2 we have PQ is equal to half AC. So here RHS are becoming equal to each other, therefore SR is equal to PQ. So here they had asked to prove PQ is equal to SR. We have proved that. Now we will look into the third question in this particular first question, that is PQRS is a parallelogram. So in order to prove PQRS is a parallelogram, we need to consider one more diagram. So we need to consider one more diagram where here in the place of taking AC as the diagonal, we need to take DB as the diagonal. So once again, I'll write this particular diagram, that is ABCD, and here we have S and R, we have S and R, and we have P and we have Q here. So we have S, P, Q, R forming inside, and now we will take this as our diagonal. So we will take this as our diagonal. So DB is diagonal of this ABCD quadrilateral. So here consider triangle ABD. So now we'll consider this triangle ABD. So in this triangle ABD, S and P are midpoints. S and P are midpoints of AD and AB. So therefore, SP is parallel to DB and SP is half of DB. This is according to midpoint theorem. So now we will consider this particular triangle, that is DBC. So this particular triangle DBC will consider. So in triangle DBC, R and Q are midpoints of triangle DBC. So that means here RQ is parallel to DB. So therefore RQ is parallel to DB and RQ is half times DB. So this is also according to midpoint theorem. So this is also according to midpoint theorem. Here you can consider this SP is equal to half DB as equation 3. So this you can call as equation 4 and this you can call as equation 3. That is SP is equal to half DB you can call as equation 3 and RQ is equal to half DB you can call as equation 4. So from equation 3 we got SP is equal to half DB and from equation 4 we have got this particular RQ is equal to half DB. So therefore SP is equal to RQ. So here we have proved that in the second question we have proved SR is equal to P, and in this particular third question we have proved SP is equal to RQ. So we have proved that SR is equal to PQ and SP is equal to RQ. So therefore, in the next slide I'll write, therefore in quadrilateral, PQRS, so in quadrilateral PQRS, SR is equal to PQ and SP is equal to RQ. So that means here opposite sides are becoming equal to each other. So if opposite sides are equal in a particular quadrilateral, then it acts as a parallelogram. Therefore, PQRS is a parallelogram because opposite sides in this quadrilateral are getting equal to each other. So in exam, they can directly give this particular diagram and they can ask you to prove that PQRS is a parallelogram. So in order to prove PQRS is a parallelogram, you need to do all these steps and at last you have to prove PQRS is a parallelogram. So starting from first question till third question, you have to solve everything and you have to prove PQRS is a parallelogram in this particular first question. So now we will move into the second question in this particular exercise 8.2. So in second question, you have ABCD is a rhombus and PQRS are the midpoints of these sides AB, BC, CD and DA respectively. So now we have to draw a particular rhombus. So let us draw a particular rhombus like this, which has all four sides equal to each other. So in rhombus, all the four sides are equal to each other. So in this particular rhombus, we'll call this as A, this as B, this as C, and this as D. Now PQRS, so P is midpoint of AB, Q is midpoint of BC, and here R is midpoint of DC, and here S is midpoint of AD. So all this PQRS you need to connect with each other and you should prove that this particular PQRS is a rectangle. So you need to prove that this particular PQRS is a rectangle. That is what you need to prove in this particular second question. So in first question, I have already solved that inside a quadrilateral, if you connect all the midpoints of all the sides of a quadrilateral, then it forms a parallelogram. So based on the explanation what I have given in the first question, you need to solve this particular second question. So here what you can do is you can take AC as one diagonal, and here you should prove that PQ is parallel to AC, and you need to prove SR is also parallel to AC. This is according to midpoint theorem. So since this is also parallel to this and this is also parallel to this, and we also know PQ is half times AC and SR is also half times AC. So that means here PQ will be equal to SR. And similarly, if you connect these 2 points, that is if you take these two diagonals, here also, here PS is midpoints of AB and AD. So that means PS is parallel to BD and PS is half times BD, and QR is also parallel to BD and QR is also half times BD. So that means PQ is equal to QR. So this you need to prove on your own. So in first question I have proved for quadrilateral. Here we have rhombus, that's it. So here you need to prove that PQRS is a parallelogram. Here you should prove first, before solving PQRS as a quadrilateral, PQRS as a rectangle, you need to prove that PQRS is a parallelogram. In first question we had proved that. So here in the place of quadrilateral we have a rhombus, that's it. So rhombus is also a quadrilateral, so PQRS will be a parallelogram. That you need to prove. Whatever in first question I have done, same thing you have to do here by connecting AC and by connecting BD. You need to prove here, you should prove that PQRS is a parallelogram. So this you need to do on your own. So just you can refer the first question and similarly you can solve this particular second question. So here if you prove that PQRS is a parallelogram, then you need to prove any one of the angle in this particular parallelogram is 90 degree. So if one angle in a parallelogram is 90 degree, then that particular parallelogram becomes rectangle. So that I'll solve now. But before that, you need to prove this. So before that, you need to prove that PQRS is a parallelogram. Similar to first question, you can refer the first question how I solved. Similarly, you can solve this second question and prove that PQRS is a parallelogram. So now in this PQRS, we'll try to prove one of the angle is equal to 90 degree. So now I will draw this particular diagram one more time. So the first part in this question you need to prove. So now I'll draw a particular rhombus like this, and here we have PQR. Yes. So here we have PQR. Yes. So this is P, this is Q, this is R, this is S, this is A, B, C, D. So here A, B, C, D is a rhombus. So that means here diagonals bisect each other perpendicularly. So according to the property of rhombus, diagonals bisect each other perpendicularly. So that means here this particular angle will be equal to 90 degree. So this particular angle will be 90 degree, this is 90 degree, and this particular angle is also 90 degree. So now in this particular diagram, we will draw a line connecting this particular point and this particular point. So let us call this point as the X and this point as Y. And here this center point also will name as O. So that means here basically we are getting a diagram like this. So here we have P, Y, O, and here we have X. So this is X. We know that this is 90 degree. So in rhombus, diagonals bisect each other perpendicularly. So that's why this particular angle is 90 degree. So here ABCD is a rhombus. So ABCD is a rhombus, and in rhombus diagonals bisect each other perpendicularly. Diagonals bisects each other. So diagonals bisect each other perpendicularly. So diagonals bisect each other perpendicularly. So therefore, in this figure, therefore, in the figure, YOX is equal to 90 degree. So YOX is equal to 90 degree, and PY will be parallel to XO. So PY will be parallel to XO and PX will be parallel to YO, because here PQ is parallel to AC, PS is parallel to DB. PQ is parallel to AC, PY is parallel to XO, and here since PS is parallel to DB, so here PS is parallel to DB, so therefore PX is parallel to YO. So here PY is parallel to XO and PX is parallel to YO. So here in quadrilateral, so here in quadrilateral, we are forming a quadrilateral, that is PXOY. So forget about connecting X and Y. Here we are getting the total quadrilateral, that is PXOY. In quadrilateral PXOY, PY is parallel to XO and PX is parallel to YO. So in quadrilateral PXOY, PY is parallel to XO and PX is parallel to YO. So that means here opposite sides are parallel to each other. So therefore PXOY is a parallelogram. So therefore PXOY is a parallelogram. And we already know XOY is equal to 90 degree. We know that XOY is equal to 90 degree because diagonals are perpendicular bisectors. So diagonals are perpendicular bisectors of each other. So they are bisecting each other perpendicularly. So that's why XOY is equal to 90 degree. Here one angle, so here one angle in PXOY parallelogram. So one angle in PXOY parallelogram is 90 degree. That is XOY is equal to 90 degree. So therefore PXOY is a rectangle. So therefore PXOY is a rectangle. Therefore here this particular angle will also be equal to 90 degree. So this particular angle will also be equal to 90 degree, that is XPY. So therefore XPY is equal to 90 degree because PXOY is a rectangle. So since PXOY is a rectangle, here XPY is equal to 90 degree. So in parallelogram, we have considered this bigger parallelogram PQRS. So we need to prove this bigger parallelogram PQRS as the rectangle. So in this PQRS, XPY is equal to 90 degree means SPQ is 90 degree. So that means this particular angle is already becoming equal to 90 degree. So in parallelogram PQRS, here SPQ is equal to 90 degree. This is because we have proved that XPY is equal to 90 degree. Since XPY is equal to 90 degree, SPQ is 90 degree. So that means that particular angle we have proved that it is equal to 90 degree. So since we have proved that one of the angle in this particular parallelogram is equal to 90 degree, therefore PQRS is a rectangle. So PQRS is a rectangle. This is because SPQ is equal to 90 degree and PQRS is a parallelogram. So PQRS is a parallelogram. So that means in a parallelogram, one of the angle is getting equal to 90 degree. So that means that particular parallelogram will act as a rectangle. So that means here PQRS is a rectangle. So this is all there in this particular video. I have solved first and second question in this particular exercise, and the remaining question I will be teaching in my next video. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.